Hello, Mr. Aaron, Mr. Ryan, how are you today? Have you had a good weekend today? Okay, sit down, sit down. Okay, so today we are going to talk about we want to count the number of pairs with the absolute difference equal to k. Okay, so you're given a number, a list of numbers like 1, 2, 2, 1, okay? A list of numbers, let's say
1, 2, 2, 1.
And a k, let's say, equals to 1. Okay, so by the way, what's the absolute difference? Do you still remember this function? ABS, x, mathematics.
It's
Okay.
X.
Yeah. What's this?
X.
Yeah. What's
1
this?
times 1. 1 times 1 is 1. Yeah.
No. This is not 1 times 1. X for x. This is the same. These two are same. Okay. This is mathematics, and this is when we do the coding, we use ABS x. Do you still remember this? Yeah. It's x if x bigger than 0. It's 0 if x equals to 0. It's minus x if x smaller than 0. Okay, so basically it's the distance. This function returns the distance between x to the 0, right? So let's say this is 5. So what's the ABS 5? What's the ABS 5? 5 units. What's the ABS minus
5.
2? Minus 2?
No, 2.
Yeah. You see? You got the difference, yeah? Okay, so so can you count the number of pairs? The pairs, yeah? Two numbers. Yeah? Two numbers with the difference equals to k. Which is 1. Can you find two numbers? Basically, finding two numbers which has the difference 1.
1, 2, and 2, 1.
1, 2, and 2, 1. Yeah? But we wanted to find the pairs. Yeah, good job. We want to find the pairs. What's pairs? Pairs, yeah? Pairs. So look, 1, 2, yeah? So if we find two pairs which has sequence, like 1, 2 and 2, 1, it's the same, right? So we want to pick 1, 2, from the big, smallest and index to the bigger index.
Can you do this?
Yeah.
1, 2.
Yeah, of course. Look, so look, 1, 2, 1, 2, 1, 2, 2, 1, 2, 1. Okay, so there are 4 pairs, yeah? But 1, 2, 2, 1 is the same, okay? We only pick one, right? Yeah, so basically if you pick AI, AJ, this is the same as AJ. You should not pick it twice, yeah? This is the same. Yeah, this is the same. Yeah, okay? Yeah? It should be easier with the proof of thing, right? With the proof of thing, yeah? Should we write it? The proof of thing. How do we proof of the pairs? Remember, what's the term complexity to proof of the pairs?
O-N square.
Well done. Wow, good job. O n squared, because we proof of the I, right? The index. And we proof of the j, right? And then we just check the difference. If it's k, then we increment the answer, right? Easy peasy, right?
Lemon squeezy.
Okay.
I got my badge.
Yeah, I'm going to find the pen. I need more. This one is good. Okay, so let's do this. Okay. Define. Count. Let's do it. Count.
Heavy.
Count. Okay. Count pairs. That's A and K. Okay. First of all, we need to know the length of the length of the pairs, length of the numbers. So, how do we get the length? N equals what? Length of the array. The number of the length. What? A, right? And then we have the answer equals what? At the beginning, we equals what?
0.
0. And then we need to do this for I in range what?
I need 4 coins.
Range what?
Range N.
Way down. And then we start from the second inner loop. For J
I need 14.
in range I to N, right? And then look, if ABS, right? Absolute function, and the distance, yeah? AI minus AZ equal K, then what do we do? We just do what?
Answer plus equal to 1.
Well done. Wow, good job. And then we return.
Answer.
You see, this is very easy, yeah? Simple. Easy peasy. 2 for loop. Starting the proof of thing. Let the computer to try the index from 0 to n minus 1. And then when we have this I, we let the computer to try the j index from I to n minus 1. And then we check the numbers, the distance between these two numbers. If it equals k, then we increment the answer. Look, this is O n and this is O n. if doing one thing, you need to on one step, and inside each n step, you need to do another n step. So the time complexity is to multiply together is on squared, right? Yeah. What's the space complexity? Come on, are we using any space? Oh, one, way down. Okay, so they on squared, not fast, so we can come up with better. So look for this one, 1, 2, 2, 1, right? So how about if I have a counter? Remember the counter, the number of each unique items and their appearance, right? So if you count that, what's the out? If this C is counter this, so what do we have for this C? 1, what? The key is 1. The value is what?
2.
Okay. And the C is 2. The unit, how many times they appear? 2. Okay. Okay. So look, the 1 appears 2 times. The 1 appears 2 times. I know there are 2 1s here. And I know there are 2 2s here. Right? 2 2s here. So look. So if I do this 1, I know it's 1, right? And what's 1 plus 1?
2.
Okay, so now I'm at the number 1. So I know the difference of k is 1 plus 1, right? So 2 is 2 counts. Okay, so I have 1 2 times, and I have 2 2 times. So how many pairs are they going to get?
2.
There are 2 options here, and there are 2 options here. So how many? 4. Yeah, 2 times 4. So look, we just count it. That's it. Yeah, we use the counter and then we count it, right? Okay, I'm going to write it, and then you tell me what's the time complexity. Yeah. So look, first of all, we need a C object. C equals counter what? Counter what? We want to count the number of elements in A. So counter A, where down. And then now I have this answer. Answer still equals to 0. Yeah. So for I in C, okay. For I in C is going through the unique numbers. Yeah. All you can do for I in C dot keys is the same. Yeah. For I in C or C dot key, all C dot keys is still the same. Yeah. Yeah. Then do what? Answer plus equal. Yeah. Look, we know Ci appears. This is the number of times Ci appears. Yeah. And we want to find out the I plus k. Ci plus k. This is the number of times it appears. So what should I do with this? Should I put what operator should I put here? Come on. I have this is 1. Then this is the 2. The number of times 2 appears. This is number of times 1 appears. So I should put. What did I talk about? What was I talking about? The number of 1 appears 2 times. The number of 2 appears 2 times. So how many pairs? How many pairs? Times, yeah, multiply together. Okay, so you can do this as well because it's going through the C, so you can also make it C minus K. It's the same, yeah? Because C minus I minus K has the distance K to I, right? The distance, okay? So it's the same, yeah? And then return what?
Answer.
What's the time complexity for this one? Come on.
Owen.
Oh, well, yeah, it's a single loop. Yeah, C, the keys appears. What? C amounts n items, yeah, n values. Yeah, On. What's the space complexity?
On.
Well done, we are using the counter, yeah. Got it? Yeah, so how beauty is that? We use this, we trade the space. Yeah, we trade the time with the space, yeah? Yeah. So we use the space to make it faster. This is linear, this is quadratic, yeah, quadratic. Yeah? Quadratic, square, quadratic. Make it linear. Linear is this one, quadratic. Okay?
I see a star.
Okay, that's okay. Okay, so look, this one we can use the counter, or we can do the counting 1 by 1. Yeah, we can count it 1 by 1. Instead of this, we can do this. Look, this is another way of doing it, but it's quite similar. Similar step. It's similar. Yeah, we use the default dictionary. Yeah, look, what's default dictionary? Integer. And then instead of going through the dictionary, because now dictionary is empty, we go into the original numbers, which is A. And then I just need to do what? I just need to answer plus equal the Ci minus K, okay? And then I also need to check the answer Ci plus K. Because these ci minus k and ci plus k are two numbers on with k distance on the both sides of the I, right? Look, if this is I, right? If this is I, what two numbers are have as a root difference k with this number? I number. Now I'm at I number. Which two numbers have difference k to this I? Come on, the absolute difference. Remember, absolute difference.
K.
I plus k. Yeah. And what's here?
I minus K.
Yeah, the k unit. Yeah, this is k unit. Okay, that's the difference. Then add it. And now because I'm at this I, so I need to ci what? I have seen one number I, so I need to what? Ci what?
Minus.
Ci is the
Plus.
counter. Plus equal what?
1.
Yeah, and then return.
Answer.
Return answer. What's the time complexity for this one? What's the time complexity?
No.
Yeah, what's the time complexity? Come on.
O.
Alright, what's the space complexity?
N.
Yeah, it's the same. It's the same as the previous one. Okay. Got it? Yeah, easy.
Yeah.
So which one you think is better? All of these.
The O N.
O N and this one. Yeah, it's good. Yeah, you understand? Yeah. Yeah. So if I erase any two, can you write it?
That's 3.
Okay. So or the second one. Which one you prefer?
That is 3, not 2.
Maybe that one is easier. Eh? You look C equals counter. You tell me what to do. Okay. Counter A. For I, we're going through the list counter. Then what? Answer what? Plus equal what? And return answer.
Answer plus equals C. I.
And
Times CI plus K.
yeah, all CI minus K is the same. Yeah, it's the same in this case because they CI. We only counting once, right? We're only counting once. So look, if 2, the K difference, we can count the
Answer
pair.
plus equals 1.
We can count the pair 2, 3, or if K equals 1, we can count the pair 2, 3, or 2, 1. This is the same. Yeah, we're only counting it once. Yeah, if you count the 2 twice, then that will be duplicate. And we are saying that we only count it once. Yeah, like 1, 2, we only count it 1, 2, not 2, 1. Okay, this is the same pairs. Okay, that's it for today. Good job.
Bye.
Bye bye. Bye bye.
Be coy.